make sure everything is kosher for sending a command, and then sent a version command that we've been trying to do for a while now. And it actually took, because it writes that value that the version command is supposed to spit out to memory location 000C. And if we do one of these, set the address to 000C and dump the value, look at that, it's 90, which is the appropriate value. So that's, you know, it's good for me. It's not very flashy, but it sure does work. And my phone just buzzed. Let me make sure it's not important. It's literally my phone letting me know that I am live. Good to know. Okay, so the next step, I think, is what we had done last time is basically you have to keep doing this loop. Wrong camera, wrong camera, wrong camera. There we go. You keep having to do this loop, basically scanning the floppy drive controller to see if it's ready to accept a command or give you some output or whatnot. And doing that at machine speed really seems to have been the thing that, like, made things work half decent. So I think I will start by losing my mind. That is how I will start. I'm going to reopen this because I feel like I accidentally made changes to it. Okay. I'm going to take, let's see if we can find that actual code. This is all monitor code. I should break this out into multiple files. This whole thing needs a horrible refactoring. But somewhere above here, yeah, we've got, you can see all of this code where it says initialize the floppy controller, that's all startup stuff. And then you'll see there's all these spots where I am doing send commands, and it's basically reading the main status register, checking its top 2 bits, seeing if it's ready for us to send or receive a thing, and that's basically it. It does that a lot. So probably a good idea for us to just take that and jam it into a subroutine because it's so incredibly straightforward. So I'm thinking, yeah, let's just make it, how shall we make it? Well, this is jumping over a bunch of stuff, so let's just put it right here, because why not? And we'll make this the send command to floppy controller subroutine. And I think I will expect the command to be sent to be an A, but also I am going to immediately push A because we need to read from 6804, and I don't feel like messing with the other registers, and I want to keep everything as much as possible. I want to not have to think about the internal state that these subroutines put my code in. So I'm thinking send fdc command, and like I said, we will just push A onto the stack, and then the same thing that we always do. So load A 6804, which is reading the master status register, and it with C0 to clear everything with the top 2 bits, and then compare that against hex 80, which basically means it's ready to do a transfer and it wants us to send it something. And let's see if it's BNE to loop until such a time as that condition is true. We should probably, you know, in better code we would do a timeout, but this is already improving my existing code, so I will take it. And then instead of doing like here, we're doing a load A to load the value that we want to send over there. We'll just pull what we had on the stack back off the stack, and then store that at 6805, which is the data FIFO register. And that's the whole thing. Then we just return return from the subroutine, and that's the whole thing. So, 1 second, I have to sneeze. Maybe I don't. Oh, isn't that infuriating? No, there it is. Oh, lovely. Sometimes when you just need a sneeze to happen, it's a very rewarding feeling. Okay, so now that I've got that written, let's save up, and I am going to check chat, see what's going on, and yeah, that's what I'm doing. Because I see some of my old faithfuls. Howdy nerds, says Trey Dempsey. Howdy right back at ya. Wereworm says evening, and evening to you, Wereworm. Trey, I hope that was enough recap. Basically, last time I was playing around on the monitor and trying to write floppy commands using the monitor, and it just was not working correctly. And then when I wrote it in code and ran it at full speed, it was perfectly fine. So I am guessing there are reasons either of slowness or something else about trying to do it manually through the monitor that it didn't like. So we went back to writing regular code, and that seems to be fine. Wereworm says, nice to see you. I suffered withdrawal all weekend. I'm sorry, Wereworm. You go find your own hobbies. They're out there, I promise you. Gerald says, hello all. Yeah, this is a party of the classics. Wereworm said, did you know you can't sneeze without closing your eyes, or so I heard. I have not heard that one. I have not. And Trey Dempsey says, bueno recap. So there we go. Short and sweet. That is today's chat check-in. Let me try zooming in a little bit here, because I have noticed that the text seems to be small on the stream, and I want it to be readable-ish. Yeah, this will do. It's so funny how it looks huge on your monitor, but like when you are watching it in the stream, I guess because you're sitting all the way back from your TV, unless you're right at your computer. Anyway, who gives a shit? Let us... Yeah, so I guess we can just start replacing stuff with their send command shit. So this should literally just be delete, 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 and call? No. JSR, jump to subroutine. Right. Send FDC command. And then we will also need, I don't know, read FDC data? Is that what we should call it? Maybe? Basically the same thing, but we want the, not only the, we're good to transfer, but the, we got a bit for you to read bit. So basically the same code, except it waits for a slightly different state, and we'll fill the accumulator as opposed to loading from it. So let's do that. Read FDC data. And that's, again, going to be the exact same flippin' thing, more or less. Actually, yeah, I guess let's yank like up here. So load, instead of checking for 80, we replace that with C0. Replace that call, which has hoisted me by my own petard many a time. Make sure I change that label. So read FDC data, and then once that's ready, we will just load A from 6805 and return from the subroutine. And that should be it for FDC, or for read FDC data. So there, abstracted. And this should make life easier for us sending all kinds of different commands, which is what I really want to do today. So instead of this whole wait on RQM thing, delete, and JSR read FDC data, and that one just throws away its data. And oh, because there's two chunks of data that the this is the sense interrupt command, which you have to send 4 of at startup. Yeah. So, oh, and we need to actually make a label here. So send sense. Oh, Don't know why I deleted that then. Anyway, so we send the command and then we read FDC data twice, but don't actually do anything with it, and that all boils down to that now, which is super nice. Nice. Super cool. So that's our whole, like, reset loop. And then, what the hell is this? I forgot what 6807 is. What is 6807? 1 second, let's review the code that I stole. It was somewhere around here. Oh wait, I didn't quite steal this code, did I? Well, I kinda did. Oh, right. Oh yeah, I didn't write that, but I should make a note for it because apparently that's setting the data rate for this floppy, which apparently this is the default for a 1.4 meg floppy, and I'm just gonna go with it. Because why waste time? I think it's kbps. Yes, it is. Okay, so that's what that does. And then we are sending more commands. So this is sending the actual version command. So yet again, we did a nice just replace everything. Load A03, JSR, send FDC command. And yeah, then why are we doing that twice? There was a reason for that. Oh, because it's the specify command, and we were sending parameters to it. That's why. So these are actually technically not commands. It's sending data, but things being poorly named is not the worst thing that has ever happened on Earth. Certainly not the worst thing that's happened to this Nintendo. So let's see. We were sending 85 down here. So let's just delete all that. Delete that. JSR. Send FDC command. And then we sent 80. So let's just boom. Now we've sent the 81. Oh wait, no, that wasn't 80. It was 21. I was looking at the wrong line. I was looking at this line. Oops. Okay, so that is the specify command, which sets up, kind of configures the floppy controller for various shits that I don't remember at this time. Now, this is the version command. So let me make more notes. Use the what was it called? Specify. Configure the FDC operating mode. And yeah, this is just sending the version command. So load a 10 is the version command number. JSR send FDC command. Delete, 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 delete. And then it's just JSR read FDC data to get the version. And then delete all this crap. And that's it. Beautiful. Cleaned right up. Let's just comment this as well. Send the version command and stash the result in 0 page. So theoretically, except for, you know, jumping to subroutines, this should be exactly the same code, more or less, as we had before. So now the test is, if we build it, will they come? I mean, will it still run? That's what we're asking. And if we're able to send floppy commands, then we're getting into like a really, really good place here. And brings me back to the thing Wereworm was asking me. I think it was Wereworm. long ago, which is, will my code in polling mode be fast enough to keep up with the data rate of this floppy drive? And this worries me. But I'm going to try not to think about it too hard. Yes. So, not thinking about that. We built it. We built it. It is built. We are loading. We are loading. We are loading here. We are hitting program. We are taking the chip out of the thing. We are turning off the Nintendo first, really getting our shit together. 36 episodes in, we had better have our shit together. 36? Is it really 36? I'm pretty sure that's what I wrote down. No, that's way too many. That's way too many. There's no way. Anyway, allow me to distract myself with the program button. And as I do that, reading, the corrupted bit says, seeing all the code in the little preview on the right really puts it all in perspective. And the thing is, it's still really not that much code. It's just, you know, when you have it all jammed into one source file, it looks long and gross. Let that be a professional tip for you. Don't jam it all into one big source file, because then it looks daunting because it is. Because you have organized it wrong. Okay, so ideally, if everything went right, this should just boot up into the little monitor prompt, and then if I look at address C, we should still see a 9. And nothing. But I kind of feel, or maybe I rather have a hope that it's spurious. It does not appear to be spurious. Ooh, it's doing a lot of weird things. I don't know if you saw that. Oh, interesting. It's gone into some kind of garbage code that keeps accessing the toggle register over and over and over again. That's neat. Okay, so it's definitely screwed up in some interesting way. Cool. Now we just have to figure out how and why. What are you doing? Why are you doing it? How do we debug this now? What do we do? I'm kind of not sure. I guess we go back to the old trusty actually look at the code approach. Anyway. Coding projects and stuff had said lack of comments, and then never mind, because I put some comments in there, damn it. And Wareworm said, my calculation was for double density, and is high density double the data rate of that? And I don't know. I guess that's the thing, is we can always knock down to a less dense floppy format if it really is a problem. RTS equals return to stack garbage. Hanging BNE loop in the beginning, Gerald says. Let's give that a look. BNE. Is this the one of which you speak? Because we're loading X, and then we are down here decreasing X and jumping back up there only if it is not 0. Which I think was the same the whole time. The other possibility is that possibly send FDC command is, maybe send FDC command is stuck in a loop. I guess we could figure this out by just like jumping to init like right after send FDC command the first time we do it, and that would tell us if it's hanging like in there or not. But let's look. So we pushed A, loaded A, checked, ended it with C0, compared it with 80, and if it was not equal, then we loop. Then we pull back off the stack and store that in 6805 to send the actual command and return to stack garbage. I mean, it does seem to be doing, like, jumping off into space. So that does make me wonder if the stack is getting screwed up at some point in here. Does make me wonder. But yeah, let's... Unless somebody else has a better idea. Gerald says, God, I can't spell. Don't worry, I wasn't judging you. Yes, let's go ahead and just right here do temp remove, god damn it, and just jump straight to init. So if it doesn't survive past this, and if it hangs before getting to here, then we know there's something up. Programming time, here we go. Load it on up. Load it fast, not slow. All right. Does it do the thing? It's got to be some kind of stack weirdness. Got to be. Okay, is it... The other option is... I mean, let's just keep moving this, right? So... Yank it. Put it after here. And... Whoop. Yes. Yes, yes, yes. And it's not like anything else is messing with X, right? Like, we just looked at the code. Anyway. Let's just see. Let's just work through it until it starts working. That's the best way to go. That's how problems are solved. Popping the chip, putting it back, programming it up. Okay. Taking bets. Taking bets now. I kind of feel maybe 70-30. 70 on this is where it breaks. Nope, terrible odds. Well, that's kind of good, because that means like our subroutines are not intrinsically broken. So that kind of weeds that out. That's a thing that we know now. So, up through there, it's all good. Now, actually, I mean, I hate to just keep moving it, but it would be good to know if we, like, for some reason don't get out of this loop. That would be, but like how? How could we possibly get out of this loop? The only things we do is send FDC command, which if I go to where this is defined, send FDC command. Yeah, I mean, that doesn't touch X at all, nor does this. It seems. Just scanning yet again to see if there's anything obvious before I just start programming willy-nilly again. But I don't see it. I'm not seeing anything obvious. So I'm just gonna keep sticking in and reprogramming, and we're bound to get there eventually. Remove me, you moron. Jump to in it. Load, 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 do the thing. Program it up like you done a million times before. Program the chip, do it good. Beedly deedly 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 dee. BNE does its branch if not equal, which also it checks the 0 register, so it is equally branch if not equal or branch if not 0. Oh, ba-da-ba-da-ba-da-ba. Hello, I am here. We are putting a chip over here. That's what's going on right now. It's going to be really funny when I get all the way to the end of this and it was a hardware thing the whole time. Oh! Oh, interesting. So it's still doing the crazy blinking thing. So it's at some point here that it loses its goddamn mind. Cool. Well, we tracked that much down. So what the hell? How? What is going on here? I don't know how to figure out what's going on here. I don't know what could be going on here. Like it's careening off into space, clearly. But what in here, if it wasn't this, and it wasn't this, and it wasn't this, what's sending it careening off into space? You know what I mean? Do you know what I mean? I feel like I'm losing my mind. Anyway, so it clearly doesn't get out of here. Let's try something really silly. Oh, sorry. Switching screens. Let's try something really silly. Remove the whole X countdown thing. Remove the whole branching. And literally just do this 4 times. Unroll that loop. I'm curious if it has the same behavior whether it's unrolled or not. You know what I'm saying? And I guess I probably should have done the same thing. Get this out of here, you putz. I kind of don't anticipate this to be any different. I'm wondering if it's something about these commands being run one after the other. I have nothing to prove it, but I just have feelies. Feelies, you see. Loading it up, doing the thing. This needs a song that's the same every time, so it can be a bit. And people will love it. But I can't think what that might be, so I just make it up and deedly-dee. We're gonna program the chip. We're gonna program the chip. We're gonna program the chip, and then we're gonna have a sip of seltzer. Okay. My breath is bated. This one I really feel 50-50. No. So it loses its mind just as much if this loop is unrolled. So it's not. Oh, also Taco Man. Hey y'all, says Taco Man, and I say hey y'all, Taco Man. Gerald says, does X ever become 0 if you DEX if F is 0? Well, it always has to pass through that at some point, because it's going to start at 4, and on one of those iterations, it's going to be 0. So, anyway, we took it out, so it's gone! It's gone! And I liked, Trade MC says, you're not losing your mind. Your mind is just aligned with a reality divergent from ours. Yes, I choose to believe this. All right, 30 minutes in. We got like another hour in us to figure this out, because of course this would be the Achilles heel of this whole goddamn thing. So the interesting thing is, like, one of these by itself doesn't seem to screw things up. It is only once I have done another one. And that is rather interesting. Let me... I am going to select all of this code, yank it, copy it off really quick. And you know, if I had been using git from the start, this would be more straightforward, but I'm just going to undo this a whole bunch before all of my changes and see if there's something obvious I'm missing in like sending the commands. Because that's possible, because it could be that like the floppy controller was waiting for me to do something that I'm forgetting to do at this point. That is making it take a shit. So, for example, let's go all the way back up to where it is doing the... Here we go. Send next sense interrupt command. Oh, that's interesting. Wait, no, okay. For a second I thought we didn't have the whole loop, but we do. It's right here. So let us compare. What line is this? 216. So give myself a little more room. Load A08. Yeah, sure. That's right. That's what we're saving here. And C0 compare 80. Is that what send FDC command is doing properly? Send FDC command. Besides the pushing and the pulling, load A6804, load A6804. And with C0, and with C0, compare with hex 80, compare with hex 80. Branches back here, branches back there, and then pulls the thingy and stores the thingy. And here, instead of pulling, it loads and then stores the thingy in 6805, in 6805. And my stack should be balanced, one would think, looking at this, because I push there and I pull there, and then I return here. Everybody should be happy. It's not something insane, like I'm like jumping instead of... No, it's all JSR, right? Right? It better all be JSR. JSR, JSR, JSR. Okay, good. I was going to be really angry if it was like a jump in there somewhere. Okay, yo. So now we want to look at read FC. So comparing that again with the code that we got going on. Load A08. And then we just do that 4 times. Oh, well, we haven't gotten past this. So here it sent the 6805, and then on the other one it would have returned, and then we're back here. Load A6804. So let's look at read FTC data again, make sure I implemented this in a reasonable way. Load A6804. And with C0, and with C0. Compare with C0, compare with C0. If it was not equal, jump back to the top of the loop. Jump back to the top of the loop. Yes, yes, yes. And then finally, load A6805. Yep. And return. And then we just do that twice. So far, I see no difference. I see no difference. Maybe someone else can tell me if there is a difference and I'm just missing it between this code and this code, except for the jumping to the subroutine and the pushing our value upon the stack. Ooh, a good question is, because this would be silly, I don't know how it would screw things up, because I can't remember what stack behavior is like if you hit the end of the stack or something silly, but it could be something silly like we're hitting the end of the stack. Maybe. I don't know how that would work. 'Cause we'd be balanced. So if we made it out of that previous subroutine, like the stack should have just as much stuff on it as it did before. But anyway, if I'm not clearing the stack, then that's a thing. Nope. We are setting up the stack just fine. Thought that might be a thing. I got excited. Oh, hey. How about, yeah. Sorry. It's been a while since I've done it that badly, but Wareworm says it's a flickering candle now. And time to build an in-circuit debugger. No, I could use the logic analyzer. I don't know what it's going to tell us. I mean, I guess it will tell us the order of execution. But why? But using it is such a pain in the dick. But this is also a pain in the dick. Indeed. Could be like some weird addressing conflict issue. I mean, why? How? How would that be possible? Where like a certain stack address screws things up when I try and access it? But that sounds insane too, right? And again, you'd think that would happen in the first couple iterations. Yeah. Friggin' hell. It's gotta be, the thing is, it's gotta be something simple. It's gotta be something simple. It's gotta be something simple that I am missing. And I just can't think of what it is. And it's not jumping out at me. Okay. Just because. Oh, also, that ain't right. But surely that's not the reason. Surely that's not the reason. Because. Oh, well, this is the wrong file. Let's copy this back out. All right, so where was I? I was going to just because double check that the JSR in it wasn't doing something weird. I mean, that would just push a return address on the stack that would never get used. But hey, why not? Let's try also something equally silly. Let's just jam this in after the second one, which I'm pretty sure will not work. But now I'm just throwing shit at the wall. Because it's one of those nights where it was supposed to go great, and so it didn't. Give me a chip. Trey Dempsey says, validate your assumptions. What do you know? You know the answer to that is jack shit, Trey. And I can validate it. Wow, it don't work. So what I know is theoretically the only difference between those two pieces of code is that one is jumping subroutines and one is not. Now, for funsies, it does look like potentially stack funkiness because of the way that that light is blinking and blinking and blinking leads me to believe you know, we've got code that's just going someplace crazy because it's not doing anything like regular, you know. It's not just like getting stuck in a loop or something. It's that light is indicating to us that it is doing something very strange and going off into memory somewhere, which is weird. But I had problems with that with the stack before, and I have ignored them. So I don't know what weird things are going on with the stack here, but let's just use the X register instead. Even though I said I didn't want to. Whatever. If this works, it's better. And then I'll ignore my stack issues again. Excuse me. So, actually wrong. Transfer A into X. And then let's do store X. Yay. So X will be dirty, but that's okay if this works. And cool. Whoops. Oh, my fingers are weak today. Weak! That is my gut feeling. Something's screwy with the stack. Something is screwy with the stack. I don't know what it could be. Are all your subroutines RTS? They should be. I don't know what else they would be. Maybe if you can get the print to work before the init. Yeah, I guess I could like print some debug messages. That would be pretty easy. That's a good call. But I mean, it's just going to tell us what I already know from putting that jump to init in there, which is when it fucks up. You know. So I don't know how useful that would actually be. Anyway, we're programmed. We got it going. It's happening. Okay. Well, I got news. It wasn't that. Which is good, I suppose. I'm waiting to see if this thing goes all flickery. I'm not seeing that. Because, you know, there's always the fun that we might have more than one issue. We could be both screwing up the stack and stuck in a loop. Could be fun. Let me... You know, I'm just going to keep trying to replace things and mix and match things because we have code that we know worked. We do. We have that. And that we have watched work just now. So, I'm going to restore some of that code. So, what is that going to be? I just have to rewrite this stupid subroutine. Load A6804, and well, why don't we just copy it like a smart person? And then store value in 6805. Cool. And so I'm going to do that for the first one, which I mean feels kind of silly because obviously, right? Obviously. Okay, I don't know how I screwed that up. Obviously, it's something about making these subroutines that it just super duper hates. So, like it probably, I just went through and compared the code and I did not see any difference fundamentally between what my subroutines were doing and what the code I had written before was doing. So, it's something about jumping to the subroutines. But whatever, I guess this will prove it. Load A, the command was 08. And store A. And don't RTS because that would be dumb. And let me just double check because why not? Yes, these both RTS. Yes, they do. Okay, let's see if this has any more. Wait, yes, if doing this, then this, is any more successful. It would also be really funny if the command wasn't 08. Let me double check that really quick. It probably is. I don't know any reason why that would have changed, but that would be funny. Because that could cause things, because if it was the wrong command... No, since interrupt is 0x8. It is 0x8. And it sends 2 result bytes. That's what it does. It's what it does. Is it... Because the other possibility, maybe that I should try after this really quick, is... didn't mean to close that. Whoops. Is... It doesn't... You don't really need... No, that sounds insane. I was going to say that you don't really need to... wait for it to tell you that there's a value to read except for the first value. Maybe you should just read them all. Would that make sense? Because maybe it's that, like I said, this sounds insane, but it was timing things before too, clearly, with when we were trying to use the monitor, that by the time that you jump to a subroutine and check the register to see if anything's available again, which we were already doing, but maybe it's just enough extra time to be marginal that it times out in some weird way, and then it's not ready for the next command anymore? Is that insane? Yeah, I think it kind of is. But that's what I've got right now. I've got nothing better. Anyway, so let's try this thingy, where I run the old way and then the new way and see if it still fucks up trying to do the new way. Load. 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 Okay. Load. Load. Hello, load. I would like to load. And then program. And I'm going to load. I just want to load. Program. Okay, we're programming. We loaded. Done. Now I'm going to load. There we go. We loaded. Fascinating. Okay, let's revert a little more, because honestly, I would have expected that to work. So let's just make sure we're not totally insane. And I'm still thinking about the things that I was just talking about, but since that didn't work, what if I just really quickly... Oh, god damn it, that wasn't the whole thing. It wouldn't have worked, ya dingus. Load A, because we didn't do the wait for stuff things. I'm going to do this, and then I'm going to read chat, because sometimes chat has ideas. Chat always has ideas. Where are we? We were here. Blah 1. Blah 1. And that is pretty much it. And then blah 2. Yay. Okay, and let's start by just making sure that much works, in case I have screwed that up somehow completely. I keep closing the damn file. And then I will read chat. Then I shall read chat. Missing semicolon, or missing colons. Come on, man. My intent was clear. Where? Here? Really? Okay. Program, listen to the wise words of chat. That's what we do here. All right. Trey said, you could try commenting out code until it behaves normally and attempt to isolate the code causing problems. More or less kind of what I'm doing right now. Eric says, I think you have an unbalanced stack in one of your loops. I'm about 15 minutes behind, so you may have already found it. No, that's exactly what I felt like too, but I don't know, like I'm not messing with the stack anywhere. So I don't know where the frick it would be messing with the stack. That was exactly my thought. That was exactly what I was suspicious of. And yet... Okay, that works fine. No crashies. No crashies at all. Now, let's do 2 of those in a row. Just regressing until we're right back where we started. I mean, now I'm just unrolling the loop that I already freaking had here. But let's humor myself. No. Let's do the thing that I was going to do. And just keep that. And see if doing that, then one of these, which the first one of these was working fine. Or at least not throwing us off into space. So if doing this and then doing this does not cause a problem, then that means it's not directly related to the floppy controller in some way. And if it does cause a problem, then that means it's potentially the floppy controller and not actually like stack stuff with calling subroutines or something, because we didn't do that before we called this one. I think maybe you see clearly what I'm getting at here. Oh my god, you guys. This is one of those nights. Sorry. Okay. All I did here was I moved one of these using the subroutine blocks up above the break into the monitor to see what I was just explaining. So if we run this and it does or doesn't work, or does or doesn't, hang or blow up, that will tell us something. Oh, I think I just loaded it. I'm going to do it again. Just be safe. PHA back to label PHA before the PLA. Oh, shit. Wait, no, but I got rid of the PHAs. Oh, wait. Oh my god, is it that obvious? Did nobody else tell me this? Because, like... Come on, guys. What do I pay you for? Thank you, Eric. Thank you very much. Yeah. Yup. Because we're looping here every frickin' time, and it re-executes this thing. This needs to be above the part where we loop back. I'm never going to rely on you guys for anything ever again. Come on. Come on. Even I figured that out. And I'm me. No, that Eric figured it out, but... With Eric's help, I eventually realized my idiocy. So come on. Whoa. Yes, so what we want to do is, let's call this send FDC check. Send FDC check. And yeah, because it wasn't particularly stack based in this part. It was just that even if you're using TXA, it's overwriting the value in X when it goes to send the command. And then all of a sudden the FDC is out of whack. So it says, I don't know, and then you try and ask it for another command, or ask it for another result value, and it says, I don't have any of those, and then all of the state of everything is all of whack. So that would do it very easily. So push A, and then only pull A down here, and I'm only going back to push and pull A yet again, because I don't really want to worry about keeping my registers clean. So that will do that. You dingus, bingus, dringus. Okay, so let's go back to, because like that is obviously it. Though it feels good when you see the thing, you know, that's always nice. So load X, nope, load X, literal 04, do all this stuff, do this thing, and then DEX branch if it's not 0 to send next sense int command. And then I don't think I had a similar thing for read FCC data, because yeah, it doesn't do anything except read, and it's not going to screw up the state of any register, so we should be cool there. But yeah, that's why that, because it was pushing to the stack a bajillion times when we were pushing to the stack, and overwriting X every time we looped there when we were using X. Thank you for saving my bacon. Thank you for being a friend. It's like the only nothing, no highbrow thoughts after that, just lol, 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 yeah. Wareham said, so missing error handling. The FTC would have told you, I don't know what you want from me. Yeah, any command that it doesn't recognize sends back hex 80. So if you were writing more robust code, it would tell you that, but I haven't. So there we go. Okay, let's go see if this did the thing. Let's go see if we got a 90, and then we'll do a little dance. Can't rhyme. I can't rhyme lately. There we go. Worked fine. Set the address to 000C plus dump 90. There we go. We're back on track. It only took us an hour. All right. 30 minutes left. What do you guys want to do now that we have spent an hour refactoring this in an unnecessarily difficult way? Ha ha ha. What interesting commands could we send to this thing? Let's read the documentation and get prepped for actually doing some stuff. Ooh, do you guys want to try and seek? Because we could do that. Because when this resets, it seeks the head all the way back to track 0. Track 0. So we could try sending a seek command for fun, and yeah, I think that might work. Why not? Let's just give it a try. Because that's the thing, is that now that we have this subroutine written, we can just give it a try and just say send command F. Send command first parameter byte. Send command second parameter byte. Wait for it to finish. The end. And see if it does stuff. The one thing is that, yes, Trade Dempsey says you need to do your namesake, which is funny because, again, when the drive powers on, it seeks to track 0, so it's already done. Well, anyway. That's fun. Sorry, just reading. Oh, you can't see. Wow, this has been like the worst night for that in all time. Gerald says, peace, got to go. See ya, Gerald. I think it was still, you caught some good material. Yes, so let's do a seek command. So we need to turn the drive motor on. We need to select the drive, but we know how to do that, bro. We've been doing that so many times. So many times. This would probably be a nice thing to do a subroutine for as well, but... yeah. So, for shits and giggles, do and seek. And the procedure for that is firstly, select drive 0. Select drive 0, motor 0 on. And that was, we've been doing this so much, but now I have to review the friggin' registers. It is somewhere. Drive selection, whatever. If the newly selected drive is a different type, then do a new specify command. We're never going to be switching drives, though. We only got the one. Life is easy. The DOR, right. And the DOR is, I totally remember where it is, but, you know, it's just for you guys, I'm going to show you that the DOR is, it's up over here. It's called, it's right here. It's register 2, which everybody knows. But, you know, I just thought I'd show that to you, just in case you didn't already know. I will need to review what that needs to be in a second here, because I remember what the motor bits are, but I don't remember the drive select bits. But the part I do know is that we will store it at 6802. That is the DOR. And let us double check. DOR. Right, so we want to set bit, right. The 4's bit, yes, and then I think these stay at 0, and that's all. Oh, and I need to make sure that reset is not set, or rather is set to 1. So that's going to be 0, 0, 1, 0. They say you can't reset IRQ, but like I clearly can. It's not set in the thing when I read it. Anyway, so that's 0, 0. So that's going to be a 4. Is it just going to be 1, 4? I think it's just going to be 1, 4. So 1 for motor A, 1 for reset over here, and my drive select is 0, 0. I think that is fine. And I might want to do that before I do the specify command, actually. Because they say do the specify command after you have changed a drive. So actually, I'm not changing the drive select. It's just the motor isn't on. And you only need to turn the motor on if you're doing drive access crap, which we haven't done to this point. So let's go for it. It's just going to be 14. And we store that. And I guess we can make a little loop to wait for the drive to spin up, but I mean, that doesn't really matter. It only matters for the drive to spin up to actually do accesses, and we're not doing that. We're just going to do a seek. So let's not worry about that. I think that's fine. So now that the drive is activated, where was it? Commands. Where was it? Oh, wait. I had it in this tab. That's why I have multiple tabs. You foolish man. So the seek command is 0xf. Do the seek command. Yo. And so that is going to be load a OF. And then call JSR send FDC command. Send FDC command. And the parameters are, first one is head number, left shifted by 2, ORed with the drive number. Interesting. Okay. Is head 0 a thing? I think everything but sectors are 0 indexed on floppy crap. So I think just sending 0 is my first parameter, right? Is all I need to do there. For head 0, drive 0. And doodly 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 doodly. And then the second parameter byte is requested cylinder number. So let's just do something. So I mean, how many cylinders does a floppy have? I have not had to know these numbers in some time. I want to say it's like 80, but maybe that's... No, because it's like 18 sectors per track, 80 tracks total. Build up primitives for send command, get result, check error, then build commands on top of that. Kind of what I'm doing, because we have, you know, I've made a primitive subroutine for sending a command and reading result bytes. So, where room says 80 tracks normally. Yeah, that's what I thought. But I don't trust my weird old brains. So anyway, we could do like halfway. Load a... Oh my god, what even would be... That's such an easy thing to convert into base 2. Or base 16. What is it? Because 20 is going to be 32. I mean, that's even fine, too. I could just write it in decimal, like I'm not a psycho. Yeah, there's an option. So let's just seek it in halfway. JSR send FDC command. And close this because I didn't need to search that. I knew it the whole time. It's 80 tracks. We're good. 80 tracks normally. I know you point that out for a reason, because you can over extend yourself and write more tracks than recommended. But no result bytes, and there will be an interrupt after some seeking. But that's pretty much that. Is we don't need to wait on anything or anything. If this goes right, then this thing should just, the motor should turn on, and then it should go, and that will be the whole thing. So let's see if we can make that magic. Just where it says, or just ram the head into the spindle. I don't think that's possible, but it would be funny. Okay, let's do the thing where we turn the thing off and then get the chip. We yank the chip out and we put it in the other thing. Then we close the thing. Then we go over to the computer and we open up the programming software. Then we do a little offset and hit OK, and we program it up, and that's the end of our day. Hopefully. Oh boy. Yeah, that's that. It's done. It is done, and now we just have this momentous occasion to see if it shall seek. I probably did something really dumb. Okay. I don't know why it does /0. Oh, it's because that button is pressed slightly. All right, so it doesn't work. The interesting thing is that the drive motor isn't even turning on. So did I for once actually not paranoia rebuild, and also it actually hadn't been rebuilt? Is that possible? I'm gonna try programming this again. That felt like it should have at least done something. Like it should at least turn on the motor. Right? Right? Yeah, because we were writing 10 to turn on the motor before. And the only thing that we aren't doing is not putting in reset. That's it. Yeah. I think maybe I just hadn't built the code. I actually believe that this time. Come here, Chippy, we do it again. I had high hopes, but then you took a shit. Why did you take a shit? This was bound to be a hit. going to do the exact same thing. And then I'm going to scratch my head and go, oh, we only solved one problem just to run into a whole other problem. That's so odd. So very odd. Okay, I'm going to... Because the fact that the motor doesn't even turn on is the weirdest thing to me. And in fact... Yeah, because if I do, like... Let's do... 6,000... Nope. Shit. 6802. And then... I guess let's dump it for starters. So it's got 14 in it. Which is weird, because that... Turned off the power supply. Let's just, yeah. Okay, that should be it. Seeks back to 0. That wasn't me. Motor's not on because... no power. Was that it? Did it just seek? You heard that, right? You heard that pretty little noise? Okay, if I turn off the power, when the floppy drive turns on, it seeks back to track 0. And now, I think that's a seek. I think it worked. I might want to up that cylinder number, just double check, because I don't know. It just makes me feel weird. It sounds like it stepped like one time, but I think it's just because it's a quite modern floppy drive. And I mean, I could just look at the head maybe if I opened the dang thing up, but I don't know. See, it makes that cool noise. Oh, let's look. Let's look. How hard is this to pop the top off of? It is not trivial. I don't know if I just jam a screwdriver into it enough, you think? Yeah, snap the top off, says Trade MC, and yes, except the top is tucked into the bottom, which is exciting. Let's do some surgery. I would be less precious and wary about this if it weren't for the fact that I don't have a lot of floppy drives sitting around. And they get rarer by the day. Sorry, just trying to find a good wedging tool. I guess I have this box cutter. I don't feel good about it, but are you ready to watch someone bleed? I can kind of see the head through here, but that's not good enough for my fans. Okay, no, I think I can get the top off from here. Yeah, I can. Easy peasy. I was worried this might not be so straightforward, but it's so straightforward. Oh yeah. There we go. Is that what you wanted? Is that what everyone wanted? That's what I wanted. It's looking good. Now I need to find a way of holding it up and also allowing you guys to see it without just setting it down and having the drive motor contact the ground and crunch into things. So I think I'm just going to hold it. Okay, so when it powers on... Oh, interesting. I wonder if that crunchy noise at the beginning actually isn't seeking. Because that seek was fast and quiet. Can I... Well, whatever. Okay, so it seeks to the center slowly for some reason. Huh. Huh. Interesting. So it just kind of, like, I think it is seeking somewhere. I think I'm probably just, like, doing it wrong. Or, you know, inputting my seek value wrong somehow. Because it seeks a little bit, and then it seems happy with it, and won't seek again. Watch. Nope. It didn't really do anything that time. It was doing things. I swear to you, it was doing things. It was seeking. It was seeking and doing a whole thing. Of course, now it doesn't know where it is. And now it does nothing. Okay, you saw that, right? All right, I'm not crazy. It just requires the whole ordeal of turning this thing off, having it seek back to track 0, reinitializing itself, and then, watch carefully. Yeah, you can't even really see it on camera, but the head, like, jiggles. So, I don't know what that's about. Where says, isn't track 0 on the outside? Okay, maybe it's seeking to track 80. Either way, it should be seeking to track 40, which should be in the middle of the thing. Why don't we, yeah, let's do that for fun, because we can. Turn this shit off. Turn this shit off. Grab this shit out of here. And probably didn't like decimal in the code. I doubt it. Decimal is, as far as I know, perfectly well supported. Nothing too special about it. But let's adjust. Let's just switch this from seeking to 40 to just seeking to 0, because if that is, in fact, correct what you say, that, yeah, track 80 is on the inside, and it's tracked all the way to the inside, then unless things are totally insane, this should go to the other side. But of course, it should have been going to track 40, so let's go to the docs really quick to make sure we're not crazy. Second parameter byte is requested cylinder number. Is it the density though? Because that's right. Because yeah, it might be the density. Track 40 might be the last track. That's what it might be, because it thinks it's a lower density disk because I haven't set the drive density. That's probably what's up. So yes. So it's yes. Blah 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 says track 0 is innermost. God damn it, track 0. Or I'm track 0. God damn it, blah blah blah. You better not be right. Either way, that might be what's up, is because I haven't set the density, I don't think, of the drive. And that would be important, because that tells it how many tracks actually exist on the disk, or rather how far to step. Yeah, I think. I don't know. It's a thought. What am I doing? I am building code. Yes, I am. That was saved, right? Yes, that was saved. Let's give it a shot. And either way, I am feeling being done with the day coming on pretty soon. Okay, chip's already in the socket. Go for it. Wareham said, but double density is also 80 tracks? Is it? I don't know. Man. You'd think, you know, a guy doing things with a floppy would know something about floppies, but no. I'm doing this precisely because I don't know shit. All right. Power on. Let's let this thing reinitialize itself. And blah, blah, blah says DD is 40 tracks per side, I think. Nope, it still just kind of takes one step back. All right. Well, I mean, it's definitely doing something. For sure. Let me tell you that. Is it maybe another weird wrapping thing where it knows that... Frick, who knows? Who knows? Who absolutely knows? Just for fun, I'm going to try one other value, but this is probably not the issue. I'm probably sending it perfectly fine numbers and things just aren't set up correctly, and we need to do more work on floppy drive setup, and that's fine. But, you know, I can be happy with clearly it's making the head do a thing, so I don't mind that at all. But yeah, let's just, for fun, let's seek to... I don't know, man. 20? 20? Everyone should be happy with 20, and we should see it do something, right? It should be pretty obvious. Right? 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 Wareham says, no, I had an Atari DD, 9 sectors and 80 tracks. Yeah, I don't know the density differences, so y'all can hash it out and I'll look it up later. Also, if I was really smart, I would have all these floppy routines get copied into memory on the Nintendo at startup and then be able to modify them with the monitor, but I'm not smart, so what do you think about that? Okay, here we go. Is it going to do anything different? I really doubt it. Nope. Jack shit. Same diff. So I bet I'm doing something wrong. On that note, I think I'll probably leave it there. It's obviously doing something. Our code is refactored. Yeah. But that's that. Just for fun, it is possible to pull the disk active bits in MSR to find when the head movement is finished. Great. Oh. Almost did it horribly again. Since interrupt command is required after this command completes to clear it from being busy, but okay, whatever. The controller tries to remember what cylinder each drive's heads are currently on. If you try to seek that same cylinder, then the controller will silently ignore it. Okay, cool, good for you. I'm thinking about looking at other people's code again real quick to get an idea of what I need to do, because I feel like it's probably set up shit. It's probably set up shit. It's probably set up shit. Yeah, so we already set the data rate. That is the register we wrote it to. I assume that specify command is okay. Controller reset stuff. Yeah. We already know that shit. Reinit. Yeah, check the version. Configure it. Whatever. I'm wondering if I have to send a recalibrate command. Could be. Well, how hard does a recalibrate command? Because we could just try that real quick. Real quick. And then I'll get out of here. Recalibrate. There's an error in the FTC guide thing. Some shit's fucked. Some statements say it'll try a maximum of 80. The value 79 is correct. Motor needs to be on. Drive needs to be selected. Don't need to wait for the thing to be complete. It's possible for to be formatted for 83. Blah blah blah. Move the head back to cylinder 0. Some debugging stuff that I won't do right away, but it's Command 7. Then the drive number. No result bytes. So I think we can just do our wait for interrupt deal. Probs. Let's see. So let's deal wait IRQ here. In fact, why don't we make that a subroutine itself? JSR wait IRQ. Get this the hell out of here. Move it down with the other subroutines. Let's call it wait FDC IRQ. And make sure it returns. Cool. And that one should be pretty straightforward because it does pretty much nothing except for read that register and wait for that bit to clear. And what I'm gonna do, I'm also going to put a wait loop here. Let's see, probably the same. Yeah, FDC reset wait loop. Just this seems to leave the light on for long enough that I can see it, and you only need a few 100 milliseconds to wait for the drive motor to spin up. And I want to make sure the drive motor is spinned up just cause. But I'm going to do the same thing, just a X loop here after we turn the drive motor on and before we start doing anything with the drive in particular. And so that will just be load X. Let's make it a touch longer, just a touch. And wait FDC motor. Oh, also before I get ahead of myself, I did not fix up this FDC IRQ. Cool. And now let us do wait FDC motor. It's going to be a little loop that just does DEX BNE wait FDC motor. The end. That's the whole thing. And then we will do some shit. I'm going to make that even bigger, just in case. It might be excessive. It probably is excessive. Then, instead of doing a seat command immediately, let's do the recalibrate command. Because that might be important for telling the thing what cylinder it's on. That isn't good enough with just turning the drive on, perhaps. So recalibrate command is 7. And the first parameter byte is the drive number, which is 0. Oh, make sure to send that command. Load a 0 for drive 0, JSR send FDC command. And now I think I just wait for the interrupt is what my hope is. This might hang. If it hangs, whatever, we're done for the day. So JSR wait FDC IRQ, and then we will leave the seat command here to see if doing a recalibrate first makes that work any better. This will probably just hang horribly, and then we will leave the night on a whoops, it hung horribly note. But, you know, we might get lucky. Load up the thing. Francois Reval says, someday I need to dig into the Haiku floppy driver and fix it. What's wrong with the Haiku floppy driver? Is it just neglected? And Wareworm says, floppy goes to the innermost track on power up to read its firmware from the disk. I'm sure. Yeah, that makes sense. Undocumented but critical behavior. I'm losing it. I'm losing it. Every time I look away from the screen, I forgot what I have done. So let's just go through the whole dang thing, rebuild the thing, and load the thing. Load it up, load it good. Here we go. Load it like it should. Here we go. Offset it, the thing. I've run out of rhymes. Ding-a-ling-a-ling. Take the chip, put it in the stuff. Try to power off first, you dumb piece of crap. Yoop. Program. Okay, let's watch this crash and burn in a most boring kind of way. Make sure that's nice and fresh. Fuck, bro. Yo. Yo. Uh-huh. That's interesting. I do not understand. But it's seeking. It just keeps seeking back and forth between, like, the outermost track and some track slightly more inboard that looks... I can believe that that's track 20. Okay. Oh, and that time it didn't do anything. Cool. Oh, I don't know, bro. I got no idea. I'm just gonna... It's fun watching it go, though. Look, we're sending it commands. It's doing some stuff. It's doing it totally goddamn wrong. But, like... It's moving that head around. Oh, boy. Well, I mean, that's not a complete fail, so I think I can be happy here. Calling it for tonight. And still going like, what is happening? Just again, just for fun. So it was really nice when it was all the way at the inside, and I just went, yeah, see, like, that looks right. When the thing is totally reset, it looks totally right. Like, it seeks all the way back out to track 0, which I feel like is the recalibrate thing, and then seeks in a few tracks, which I feel like matches with the number of tracks in we were looking at. So, why turning it off and turning it back on makes it behave weirdly? I don't know. The whole controller should be like going through a whole reset cycle when I turn this on, so... Don't know. Don't much care. Because if I do it just right... Let's do it again. One more time before we go. Are you ready for it? It's very satisfying. I'll take it. I will take it. And if you don't like it, that's fine. Oh! I wonder if... Well, no, because I was completely turning off the thing. I was going to say if the hardware reset wasn't enough, but, like, I don't know. Let's not worry about it. I've worried about enough for today. And we have a drive starting up and seeking to what seems like a reasonable track number. Wareworm says maybe the FDC gets some 5 volts via the floppy cable. Could be. But, I mean, it's already getting healthy voltage from the power supply, so it's like... That kind of bleed shouldn't really make a difference once the floppy drive is on. And again, it's going through like a full reset cycle of the controller, which should involve like that reset, hardware reset, and then software reset, and then I'm not worried about it. Look, let's just keep pressing forward, because if it works correctly from power off to power on, I'm okay with that. We can clean it up later. We'll have a whole series on cleaning everything up, but okay, one more time. One more time. Wareham says, I mean, just turning the NES off may not be enough. But I'm saying I'm doing the whole reset in software from the beginning. So that's supposed to work. But I'm probably not doing it fully enough. I'm clearly not doing it fully enough. I think we're on the same page. Let's just do it one more time. And then I gotta go. And then I gotta go. Just say the reset button should work. Because I'm not sure. It actually probably should. My only question is the reset toggle register BS, but I think it will. Well, we'll just have to see. Anyway, that's very satisfying. If I do this. Well, using reset on here just ain't happy with that. Okay, anyway, cool. We're seeking. Seeking is happening. Let's go. All right, goodbye. I need to go do other things now. Thanks for tuning in. That was some progress. It was. It was a lot of struggling, but like, hey, seek is clearly happening now. I'm happy with that. So, yeah. Until later. Until next time. Until tomorrow, presumably. See ya. Love ya. And what is it I say? Bye.